And okay, so thank you again for joining. This is a webinar on skimmer basin design. Today we're going to focus on requirements for North Carolina and Virginia. Um, if you've joined us before, a lot of this information is going to be similar. Hopefully we've got a lot of new people on today and provide some information that you can use in your um, on your projects. That out of the way. There we go. So my name is Jamie McCutcheon. I am a 1992 graduate of Clemson University with a degree in civil engineering. I founded CCAD Engineering in 1999 and owned it for about 20 years before I sold it to another engineering company. Invented the Marley float skimmer back in 2013. Quick story on that. South Carolina, where we're based, had adopted a new construction general permit in 2013. Leading up to that, DHEC, our state agency at the time, was going around educating engineers as far as what the new requirements were going to be. Uh, One of those requirements was for surface dewatering sediment basins, i.e., using skimmers or floating outlets. Um, December of that year, our daughter, who was 11 at the time, had a bad night. She wanted to sleep with my wife and I. Like I said, she was 11, and so it had been several years since she'd done that. But anyway, she's a little ruder, so I had elbows, knees, in the back all night, so couldn't sleep. And for whatever reason, we thought of a skimmer. Over the next several months, 6 to 9 months, we developed that into a product. And when we decided it was time to try to market it and sell it, had to come up with a name. So we named it the Marley Float Skimmer after my daughter Marley, who inspired the invention. So today we're going to go through a couple of things. We'll do just an introduction to skimmers or floating outlets. We're going to run through the basics of skimmer basin design. They're similar for most states. We're going to focus on Virginia and North Carolina today. Virginia just recently started requiring skimmers or enforcing that requirement more so. And North Carolina, they had some updates to their manual this past year. And so a few changes there, nothing major for North Carolina, but a couple of things we'll touch on. Then we're going to pivot and to a kind of different topic. We're going to talk about using skimmers for post-construction, why you may want to do that, go through a little case study we've done before on that. And then if you do want to use it, you need to know how to model it. So we'll talk about how to model it at HydroFlow, which is probably the most common software. And then we're going to wrap up with talking about the Rymar water quality filter and a filtration-based design, which is a new concept that is out now and want to get you familiar with it. So, all right. So first thing as we get going here, I'd like to know just how familiar you are with skimmers. So I'm going to launch a quick poll here. And if you could just give me a quick answer of, are they new, you know, a lot about them or somewhat. So give this just a second. Appreciate everybody answering quickly. All right, got most people have answered, so we'll share those results. It looks like a couple few people, three people here, they're new. Probably the majority of you, eight or so, are somewhat familiar but like to learn more, and then several are very familiar. So appreciate everybody joining. Those that are familiar, hopefully you'll learn something when we get into the post-construction side. All right. So for those that are, you know, maybe not as familiar or need to learn more, you know, we used to do it this way. We used to have a riser structure with a check dam, but typically there's an outlet at the bottom of the pond. And as you see in these photos, you know, you're discharging from the pond from the bottom where the sediment accumulations are highest. And so skimmers have been around now for, I guess, 20, 25 years, different places, but they withdraw water from the surface or near the surface. You've got that much cleaner water at the surface relative to the bottom of the basin. And so that discharges that cleaner water and allows more time for the mud to settle. And you know, they've been shown to greatly increase trapping efficiency. Our skimmer is a little bit different than some others in that it takes water in from about 2 to, well, it's really not 14 inches. The skirt here, we have a debris guard that's about 14 inches below the surface. So the water comes under that guard into the skimmer and out, but we don't take it directly off the surface. So there's a little advantage there is that you've got any floating trash and debris stays in the basin longer unless obviously it tops over the riser and then it could be discharged. So there's a number of skimmers on the market. The Faircloth skimmer, I have to recognize them. They really kind of started this as a brand. The erosion supply is kind of similar to Faircloth. Marley float is us, and then IES skimmer. This is a little quick video of a site over in Anderson, South Carolina. It's about 8 acres disturbed area draining to this basin. And you can see in this video, it's very muddy, dirty water. This site discharges to a lake that's about 100 yards from this outfall. You can see there the outfall is actually relatively clean water. So the skimmer is doing a really good job of not sending a lot of turbidity to the lake, which was really important for the client in this case, so they didn't get a lot of complaints about turning the lake brown or red. So real quick, there's basically three fundamentals when you're designing a sediment basin. Fundamental number one is basin volume. So your basin volume is going to be based on the area flowing to the basin. The regulations differ state to state. Most of them require you to base that on total area. Some are based on disturbed area. What we see most common is anywhere from 1,800 to 3,600 cubic feet per acre flowing to the basin. Some areas, Indiana's higher, around 5,600 cubic feet. Some areas require you to calculate it either based on a 1 year or 2 year storm. But for this example, let's just say we got a 5 acre site and the area is requiring 3,600 cubic feet. That'd be 18,000 cubic feet required. Some areas, Ohio, Indiana, and Texas are among them, also require a permanent pool. Virginia also has this requirement for those from Virginia today. And so that portion is not included in the required volume and not used to size the volume of the skimmer. So you want to use the required volume, in whatever area you are to determine the size for your skimmer. Fundamental number two is dewatering time. So again, the idea is to allow time for the sediment to settle. Obviously, depending on your soil conditions, this may vary. What we see is the most common standard is 2 to 5 days or 48 to 120 hours. Again, that varies. Some states have a 2 to 3 day time frame, so just a 24-hour window. Other states say in less than 3 days. So it just depends on your state and your MS4 what they require. But we see 2 to 5 is the most common standard, and 3 days is kind of the typical target when you're sizing your skimmer. And number three here is just flow rate. So it's really simple. Basin volume divided by dewatering time, that's going to give you a flow rate. And so, if let's say, for example, if you had a 2 to 5 day range based on our 18,000 cubic feet per day, the flow rate for your skimmer could be anywhere from 9,000 cubic feet per day to 3,600 cubic feet per day. And you've got a pretty good range in there. One thing to note is a lower flow rate will often result in a smaller and typically less expensive skimmer. So sometimes if you go to 3 or 4 days, you may drop down a skimmer size. This is actually a plan that came in recently just to highlight the importance of required storage versus provided when you're sizing your skimmer. So this is actually a note off of a set of plans we received recently. It had a 1,754 cubic yard required volume, but 74, 78 provided. So substantially different. What's that? Maybe 4 or 5 times, about 4.5, 5 times the provided volume versus required. The engineer has specified an 8-inch skimmer for this. And he specified us, which we appreciate. However, if you size the skimmer based on the required storage of 1,754, you would only need a 3-inch skimmer with a 2.5-inch orifice. If you size it based on the provided storage, it's the 8-inch skimmer with a 6.5-inch orifice. Substantial difference in cost here, over $4,000 difference in cost for just that one item. So, we want to, number one, we want to meet requirements. And so, using that larger skimmer is going to discharge this smaller volume faster. And so it may be in less than that 2 or 3 days, whatever that requirement is, but you're also going to have a cost implication. So I really just want to highlight that as one of the key items. It's very common. I'm not naming this engineer, not picking on anybody, but it is the most common mistake or error we see when we get plans from our distributors that engineers have based the skimmer size on that larger provided volume in the basin. Now, I will admit, and I haven't talked to this engineer, sometimes that's on purpose. Sometimes you may have a site, let's say it's near an airport, and we've got to get the water out fast. And guess what? That is more important to not attract birds and create hazards than it is to meet the exact letter of the law and requirements. So this may be one of those sites. I'm not saying that what the engineer did here is a mistake, but you know, typically you want to size it on that required versus provided. All right, so we ask another quick questions, kind of keep everybody engaged here. So I'd like to just have an idea, where are you from? Let me find my phone. There we go. And so got a couple of choices for you on here, and there's also an other. So awesome. See a couple of people from Virginia and North Carolina. That's great. We were trying to focus on those and kind of get that out today. Um, and really good mix. Looked like I'll end the poll and share it. So it looks like other won today. So if those of you that are other want to put it in the chat, I'm always curious to know where people are coming in from, and I can kind of tailor the presentation to those specific requirements. So, all right. Good group from Ohio today too. That we appreciate that. So keep them going here. Let's jump into the Virginia Sediment Basin Standards. Again, Virginia just recently, we were up at the ICA conference in Richmond. I don't know if any of you were also there. Um, I saw some chat comments. Tennessee, Alabama, Pennsylvania, Central Massachusetts. Welcome from them. So, all right. So, if any of you were at the ICA conference in Richmond recently, talked to several of the folks from Virginia there, and they all said, "Hey, we're going to start requiring skimmers." Well, their detail doesn't show a skimmer yet. This is, out of their manual, but that's okay. They'll, it takes a while for these manuals to get updated. They do require 67 cubic yards of what they call dry storage. And they also have 67 cubic yards of wet storage. So the wet storage would be below the invert of your outlet pipe, either perforated riser or skimmer. And you would not include that in sizing your skimmer. You would just include the dry storage volume. They state that half, they've got a total of 134 cubic yards for the total contributing area. Half of that is dry and half of that is wet. They also have a sediment clean out of half of the wet storage. So once your sediment reaches half full for your permanent pool, time to get it cleaned out there. They also ask you to design the outlets to handle the 25-year storm. If the principal spillway is used in conjunction with an emergency spillway, which is going to be the case most of the time, your principal spillway is going to need to pass the 2-year storm, and your emergency spillway would pass the 25-year storm. Again, they have, thought this was highlighted. So they have a 24 to 120 hour time frame. But then they say down here, if you use a skimmer, you drain it in 2 to 5 days. I'm not sure why they have a difference of 24 hours up here, and then 2 to 5 days, but that's what's in the regs. And they also say dewatering from the surface provides greater trapping efficiency. So that's one thing we want to focus on, is that skimmer really does a good job, like I saw in the video, of trapping that sediment. Now switching real quick to North Carolina, in their CGP, and most places have this, they state, that you must do surface withdrawal requirement, and most common way is with skimmers. In North Carolina, any sediment basin or trap of 1 acre or more shall use an outlet structure to withdraw water from the surface, unless this is infeasible. A lot of states have that infeasible clause in there. It's pretty rare that you're going to see that. The only time that you're really going to see that is if maybe freezing conditions. So I've got some people from Ohio. I've been doing some stuff in Indiana, Minnesota lately. If you're in an area that's going to have significant ice, you need to make accommodations for that. Maybe have a perforated riser with a valve on it or something for those times if you had a frozen pond. North Carolina, again, 1,800 cubic feet of storage per acre for the disturbed area, not the total area. They have a minimum dewatering time of 48 hours. You got to withdraw from the surface. And again, the skimmer should be sized to dewater the basin in 2 to 5 days. So you got the minimum time of 48. Down here, they give you maximum of 2 to 5. This is the new DEQ sediment basin design standard. Has that same information here on the detail. They also have a minimum surface area, 435 square feet. And then they have a skimmer sediment basin design detail as well. Both of these just came out September of 23. So, and then North Carolina does state, North Carolina previously had some information in there about specific skimmers. They have taken that out, and they say very clearly any skimmer design that dewaters from the surface at a controlled rate is acceptable. Our friend Mr. Faircloth is from North Carolina and did a good job of getting out, and most engineers were familiar with him, especially in North Carolina. Um, but North Carolina DEQ has made it clear, they'll accept any skimmer design that does dewater from the surface at a controlled rate. Typically, the main thing is to know what that rate is so you can meet the requirements. I'm aware some contractors even build their own. As long as they know what that flow rate is, that's fine. I will say that's a lot of work involved to confirm that, but they do allow that. So, a little quick summary here. We've got South Carolina, North Carolina, Georgia, and Virginia included today, but I do this just to give you an example of how requirements do vary from state to state. So, if you're an engineering company that is working in a variety of states, just be aware, what you used to doing in North Carolina may not work in South Carolina, may not work in Ohio. So, South Carolina has 3,600 cubic feet per acre for the total area as their volume for a basin, where North Carolina is only 1,800 cubic feet per disturbed acre. Georgia's 1,800 cubic feet as well. And they don't say, as far as I know, disturbed or total. So a little bit of up to the engineer there if you have some of both going to your basin. And again, Virginia is that 134 cubic yards total, with half being wet and half being dry. Surface area, there's a couple of different formulas out there to make sure you meet the surface area. The idea is you want to spread it out and give enough area that the sediment can settle, not just have a narrow or small surface area with a deep basin. Virginia has a minimum length to width ratio. You got to meet 2 to 1, or you got to put in baffles. Didn't touch on baffles, but most states now require some 2 to 3 rows of baffles in the basin. The baffles do a great job of just slowing the water down and spreading the flow out. Where you have baffles installed, you'll see significant sediment deposits on the upstream side of the baffles. Principal spillway, anywhere from 10-year to 2-year storm. Emergency spillway, anywhere from 10-year, 25, or 100-year storm. Where skimmers are required, it varies. Again, North Carolina is 1 acre or more. South Carolina is 10 acres or more. What we see is if you have an outlet structure, they typically want a skimmer. If you just got a rock, like a sediment trap with a rock outlet, obviously skimmer's not going in there. The rock outlet's doing that. But in general, if you have an outlet, riser type device, you want to have it. In North Carolina, with that 1+ acre, you got to be a really small basin. If you're under an acre, you probably don't even need a setup basin. You can probably do it with silk fence or some other BMPs. In Georgia and Virginia, they're preferred and they're probably more required by MS4s. At a state level, both of them are starting to say, yes, we do want them. Again, dewatering time, 3 of these states have 2 to 5 days. Georgia doesn't specify a standard, leaves it up to the engineer. So one of the things that is a little misconception on skimmers is that they're constant head, constant flow. This table came from a study done by TRI Environmental for Georgia when they were updating their erosion control manual. And they found that when they tested skimmers, in this example, they tested 3 different 3-inch skimmers, and all of them increased in flow with depth. Now, 2 of them had a flow of about 37 GPM at a depth of 1 foot. One of them had a flow of 70 GPM, so nearly double the flow rate. All 3, as they increased in depth from 1 foot to 4 feet, had about a 25% increase in flow rate. Again, 2 were similar, close to 50 GPM, and 1 again is not quite double, a little less than double at 90 GPM. So the critical thing here is that if an engineer just specifies 3-inch skimmer and they don't give a brand, they don't give any other information, and the contractor's free to pick any 3-inch skimmer, well, they may pick the one that flows at 70 GPM, or they may pick the one that flows at 37 GPM. And so you may get the flow rate you wanted, or you may not. So really important to specify that flow rate. And also we do recommend, specify, the brand of skimmer that your design's based upon. Most engineers now put up or approved equal. And so if the equal, say you specified the brand that's, got the lower flow rate, well, the other brand knows, hey, we don't need a 3-inch skimmer. We may need a 2.5-inch skimmer or 2-inch skimmer, whatever that their size is that correlates with that flow rate. And so they get the proper device and proper flow rate on site. Um, we do have some design tools on our website. They're simple Excel tools. We have one that does, includes a permanent pool. This one is just for dry basins. So give you your place here to put your project information, your date, project name, location, engineer, company and name, basin description. We give you some other, sometimes you may have, hey, this is for phase one and phase two. It needs to be something different. If you've got, different areas going to a basin during different phases. One thing we added, and this was done at request of MS4s, is this check here. So what's your required dewatering volume? So what's the area to the basin? That's going to be either disturbed or total, depending on your state requirement. And what's that requirement per acre there? So if you're in a state that has where you have to calculate that, you can just kind of plug in some numbers here to kind of get close to that. Um, but most states have a set volume. So then what you're going to do is come over here to this table and you're going to put in your minimum and maximum time to drain. Again, 48 to 120 hours is common, but you adjust that as needed. Your pond depth. Now it's really important that you put the depth required to reach this volume. If your basin's 6 feet or 8 feet deep, but you only need 3 feet to reach that volume, then put in 3 feet here. Your top length and width and bottom length and width. Again, we don't see very many square or rectangular basins, so use your engineering judgment to adjust these numbers so that the calculated pond volume, we typically recommend try to get within 5% of this required volume. Again, we typically have at least 24-hour to maybe a 72-hour range of time. So you don't need to necessarily go in here and put 120.25 and 34.36 in order to get it exactly there. When you do that, the spreadsheet's going to factor in the flow rate curve for each skimmer with each orifice size. And then down here at the bottom, we've got a skimmer report page tab. I know you really can't read all the spreadsheet there, but it's going to take you to a nice, neat 8.5 by 11 that you can put either on your plans or in your SWIP. The top half is going to give all your information, and it's going to give this check right here so that the reviewer can see very quickly, yep, our calculated pond volume, we're basing the skimmer on, and our required are very close. Here's the minimum flow rate to drain in maximum time. Here's the maximum flow rate to drain in the minimum time. And then because it is our tool, we're going to tell you which one of our skimmers meets that specified range of time. Again, in most cases, the target's about 3 days. So we would probably say, hey, for this site, our 2-inch with a 2-inch orifice to drain in 69 hours, that's probably the one to select in most locations. Obviously, depending on your state, you may have different requirements. You may be close to an airport, you want to drain it as fast as possible. So you're going to go up here to the 4-inch with a 2-inch orifice, just barely meet that 2-day time. You may have a really clay, silty soil. You may decide, hey, I want it to take longer. I can go all the way out here to 2-inch with 1.5-inch orifice and take, nearly the whole 120 hours. So anyway, up to the engineer which one you pick within that range. We have several sediment basin details on our website. We have 2 that'll have just a pipe through the dam. For this would be more like temporary basins. We have one for a dry pond, one for a wet. And then we have 2 with riser structures. Again, we have this one will be for a wet pond. We also have for dry. Over here in this chart gives you your information that's going to apply to all the basins on the site. So if you have a length to width ratio, minimum and max, what's that sediment storage? Again, that's the below invert. What's the dewatering volume? That's above the invert based on the skimmer size. Surface area. Here you're going to set your minimum and max dewatering time. So right here, engineers, you're setting this so that your MS4 is reviewing that and confirming, yep, that works. We can work with that. Down here is going to be your sediment storage and make sure your provided meets the required. Your dewatering volume, again, you want to base your design on required. provided often is much more, especially if this pond's going to be a detention pond once you finish construction. Then you're going to have again, your basin number, drainage area, disturbed area, flow, surface area of the basin. Um, and then here's all of your important information: the bottom of the basin, the outlet invert, barrel, top of riser, spillway, etc. To get over here to your skimmers. So you can have your skimmer size, your skimmer orifice diameter, the skimmer type or brand. It's our details. We filled in Marley for you, but change that if it's something else. Is an equal allowed, yes or no? Now, the majority of the time, that's going to be yes, and we fully expect contractors to have options when they go do that. And then if you have that, specify the minimum and maximum flow rate right here. So if a contractor calls you up and says, "Hey, I've got this other skimmer, it's this size, and can I use it on this project?" You can look real quick. Hey, does that skimmer have the right flow rate? Yes, it does. Okay, it's fine. Oh, sorry, that one's too small or too big. Really shouldn't use it unless you change the orifice or something else. So easy way to do that with a shop drawing, not having to go back through a full review. Um, our detail here is, I guess, a couple of things just to point about it. We don't use, we have standard orifice sizes for all of our skimmers. So they come with what we call an orifice plate. We'll have a little video about that later. That's the flow rate for each skimmer. I know you can't read that, but that gives the flow rate for each skimmer with each orifice. This is the most common asked question is how long does this pipe need to be? We recommend 1.4 times, but a minimum of 8 feet. Some places have a minimum of 6 feet. That'd be fine. But you want 1.4 times the height of your riser structure. So if the riser structure is, say, 8 feet tall, you want about 12 feet or so of pipe. If the riser is only 2 feet tall, you still like to have 6 to 8 feet of pipe out there. The idea is that when the skimmer gets to the top of the riser, it's at about a 45-degree angle. And that helps with the function of the skimmer. Here is a skimmer installation that's been shown. So this is a new pond. Obviously, it's just been constructed. Got your baffle in, sides are tracked in, outlet structures in there. One thing to point out here, if it's intended to be a dry basin, we really want a depression here so that you've got the skimmer sitting down so this basin will drain out. If you don't have that, you're going to tend to hold anywhere from 6 inches to a foot of water in the basin, make it harder to get grass established across the entire basin. This is probably the worst install we've seen. An inspector sent us this photo. There's no flexible cupping here that we can tell. The skimmer's kind of sitting on the rock. Obviously not going to float up, not near enough pipe, but they've got this valve open on the side, so the skimmer's probably not doing much anyway. Water's just kind of bypassing it and going through. We have had some skimmers installed upside down, which is surprising because there's a sticker on the top of the skimmer that says this side up and has a QR code that takes them to an installation video. So if we got any contractors on today, we try to make this as simple as we can and give you all the instructions you need to make sure it's installed correctly. And then this skimmer, had some issues. You can see the sediment basin needs to be cleaned out. The pipe's sitting up on mud, but this skimmer actually had vegetation growing out of it. The pond would never really drain, and it was because there was a big root ball inside the skimmer that was clogging it up. So if you see vegetation coming out of the actual skimmer, there's probably an issue and needs some maintenance. So that kind of wraps up our during construction. If anybody has any questions, like I said, feel free to put them in the chat, or if you'd like to unmute, ask anything, I'll be glad to listen. All right. We'll roll on then to permanent use of skimmers. So I'm going to ask you another quick poll. Have you ever used or considered using a skimmer permanently? And this is one poll that I always get a little excited about. See if we have any yeses. I got 2 so far. That's awesome. A lot of no's, which we typically expect, and then got a few that say they've considered but haven't yet. So got about 3/4 of you done's will end that, share it. So majority have not. Over almost 60% said no. 30% said they considered, and about 10% said they've done it. So that's great. Love to hear that. So have not done or have considered it, we'll run through why you might want to do that. So, we've got here is a typical dry detention basin. And so what happens is you convert the pond from a sediment basin to permanent. You're going to remove that skimmer. You're going to put in some sort of low flow orifice here at the bottom to control that first flush. And then you're going to have some sort of guard or filter to try to minimize clogging. But again, the whole intent for water quality is we want to hold some water in the pond, give time for the sediment or other pollutants to settle out before it gets discharged. But like we used to do in construction and we don't do anymore, we've now reverted back to discharging from where that sediment pollution concentration is highest. So, maybe that's not the best design. So then, basins rely upon the natural settling of sediment particles. There's going to be some fallout. You're going to need, you don't want to short circuit. You want to have some distance from inlet to outlet, so you got time for it to settle. But skimmers are going to release that cleaner water from near the surface. They are pretty much, common now for most areas during construction. They've proven to be very cost effective. So if they work so well for construction, why would we not consider them for permanent use as well? So there's a little quick case study. So this was a pond that was severely neglected and overgrown. Went in and cut all the timber out of it, and I do mean timber. It had 6 and 8 inch trees in it, and you can see here, kind of through the tree limbs, there's a couple of orifices here, but it's ponds holding water, and it was not. We thought it was intended to be a dry pond, but it had no low flow orifice that we could find. Let's skip over the last quick picture here. So we did some research. We actually found out there's a 2 inch orifice 6 feet below the now bottom of this basin. And so we worked with the owners, and it was going to be $75 to $100,000 project to go into this basin, excavate all that muck, and dispose of it. And we said, maybe this basin has some extra volume. Let's look at it. So we ended up redesigning the basin, closed in the orifices here, added some more a little higher. And instead of going back with a 2 inch orifice, we went in with a skimmer. And this skimmer had I think, a 4 or 5 inch orifice in it. Well, the area that this was in did not allow skimmers for permanent use. It had never been done. And, they weren't sure if they wanted to do that. So we had to do this as what they considered a pilot project. And they required us to monitor the skimmer monthly and provide reports for the first 12 months to make sure it's working properly. And then we went to quarterly for the next 2 years. And so we did so. We actually maps camera, went out there, took, did inspections, watched it very closely to make sure everything was working right. So about a year later, the owner was now doing maintenance. And so they had landscapers go out and cut the sides of the pond. This pond has very steep, it's like 1.5 to 1 side slopes. So they just let all the debris fall to the bottom and they were going to clean it up. Well, they had a big rain, about 5 inches of rain in just a few hours, big summer thunderstorm, and washed all that debris down into the bottom of the basin, to the outlet structure. But you see the skimmer, sitting there amongst the debris, but was able to do that. So see a question in chat, and I'll get to that in just a minute. So the idea here is if this had been a 2 inch outlet, it's hard to tell. This is a 12-foot riser. Remember, there's 6 feet underground, so these are 6 foot sections. So this is 8 or 9 feet of depth here. So if this was clogged with a 2 inch outlet and water was staying up at this level, it would be, dangerous, very difficult and dangerous to go in and unclog that. This trash rack weighs about 200 pounds. So, it's not like you can just climb up on a ladder and one person, climb down in it to do that. You may need scuba gear to actually get it unclogged. So, with the skimmer, even if it were to clog, you just pull it over the side. Worst case, if you forgot to put the rope on it or rope, didn't work, you had to float out to it, but at least you could get to it, relatively easy compared to getting to something that's 8 or 9 feet, underwater. So, got a question about HydroCAD, and I'll touch on that real quick. We're going to jump into modeling in HydroFlow. So if you wanted to use a skimmer permanently, you got to do it. HydroCAD, we actually are included in HydroCAD under their special and user-defined outlets. And so if you want to shoot me an email later, I've got a presentation that's about to go up on our website on modeling in HydroCAD, but I'll be glad to talk to you about that. But let's talk about HydroFlow. HydroFlow seems to be one of the more common hydrology modeling products out there because it's now built into Civil 3D. So let's look at how you would model a skimmer in HydroFlow. So this is an actual site that was done many years ago. It's in an area that requires quantity control during construction. So this is actually a sediment basin, but they did require quantity control calculations. So we had about 5.25 acres, 5.5 acres going to this study point. We were disturbing about 2.25, putting a little small sediment basin here, and then the rest of it was staying undisturbed or natural. So pre 5.5 acres, curve number of 59, it was wooded. Time of concentration was just under 20 minutes. Post, the undisturbed portion will stay the same. 2.25 acres, disturbed earth condition. So we used an 86 for bare earth disturbed condition. Time of concentration was 7 minutes. When you build your basin, you want to build in a stage so that you can enter the flow rate for the skimmer. So in this case, we did 0, 0.1, 0.3, 0.5, all the way up to 4 feet. The basin just happened to be 4 feet deep, which happened to correlate with our testing of the skimmer. Again, our details, in this chart for each skimmer, each orifice configuration give you that flow rate at 0.1, 0.3, then every half a foot up to 4 feet. And so then when you plug in your outlet structure, you're going to have your outlet pipe. In this case, we had an 18-inch pipe going out. We had a 6-inch orifice and the riser structure at 1.75 feet above the bottom. We had our riser structure, which is about 3.6 feet tall, and we had a rectangular weir at 3 feet above the bottom. And then here's kind of the secret sauce to putting in the skimmer is this user-defined column. So again, we manually plug in the flow rate off the detail at each stage you created. Now, obviously, I did this as an example. When you go to do this in real world, you probably could put in every half a foot and be fine with your flow rates because it doesn't change that much every half a foot. But, to accurately model it, I did put in, each data point. Now, what happens if your basin is over 4 feet deep? You've got a couple of options. Number one is you can just hold that 4 foot flow rate because if you look at the skimmer flow rate curves, most of them flatten out around 4 feet, so they're not going up as much after that. You can extrapolate it. I'd recommend use the last 3 data points and extrapolate it out. Or if you've got a really deep basin, let's say, a lot of times these ponds may be getting 10 or 12 feet deep when they're post-construction. You go into our tool that we looked at earlier and put in your pond depth here of whatever the full pond depth is. So in this case, we've got 8 feet. If you do that, our tool is going to break that pond depth into 20 different increments. And so then you can go look at these increments. I would probably pick one that, the closest foot, maybe 1.5 feet. In this case, I've got like 14 inches and 2 feet. And there's kind of, between 3 feet, 4 feet, so on. But plug that in, and it's going to give you the flow rate at each incremental depth. Now, in this example, I'm showing our 2-inch with a 1/2 inch orifice, so you're seeing no change in flow rate here. If you go up to the larger skimmers, you're going to see a lot more significant flow rate change as you go. But that's a way that you can then put these numbers into your HydroFlow and model that actual flow rate at each depth. When you go back to HydroFlow, you're going to see if you look at a schematic of your riser structure, go back there. You've got a top of riser, your rectangular weir, your orifice. Normally you'd have a hole here at the bottom for your low flow orifice. You're not going to have that here, right? You use user define instead. But when you look at your stage discharge curve, there's your discharge from your skimmer. So it's modeled in there correctly. That's when your orifice kicks in, your weir kicks in, riser kicks in, and so on. So that's how you would model that in HydroFlow. And again, HydroCAD's pretty similar. The advantage to HydroCAD is you can just pick the skimmer and it'll plug in that flow rate for you, and it'll also extrapolate out for you in HydroCAD. So it makes it a little easier to do. So got about 20 minutes left here on an hour. So we'll talk about advanced skimmer modeling for filtration-based water quality. So this is really a complete change in idea for how you're going to achieve water quality in basins. Um, so we've developed a new filter, goes around our skimmer. So the outer side is a polyethylene fabric. The inner skirt, we have this two-stage, is a non-woven called Adsorbit, and then you've got the skimmer discharging. So the idea is that the skimmer's pulling flow through these filters, or the filter hangs 3 feet deep. It's open on the bottom. So the idea is that if a particle settles down here, there's not enough force for the flow to pull it back up and get discharged by the skimmer. We're letting gravity do the work at over 3 foot depth, and the top 3 feet of the pond is having to go through the filter before it gets discharged. So we've been developing this for many years. Go back to that same pond that we looked at before, and this was our prototype. This was probably the, I don't know, sixth or maybe eighth different prototype that we'd used or come up with, and we finally found one that we felt pretty good about. So we're later on we're going to look at maybe metals, hydrocarbons, other pollutants. Understand Florida is putting in some stringent nutrient requirement removal requirements right now, so may look at we can effect on that. But so far we just looked at TSS. Here's kind of an up close view of it. Again, for our prototype, we used a turbidity curtain that had a screen in it, a polyethylene screen that would let water through, and then that's the non-woven absorbent. You can kind of see in this picture, it's actually got slits in it. So this is 2 layers of fabric, and they're set up so that they have basically 6-inch panels with a slit there, and the panels are offset. And so the water kind of either goes through the fabric or it weaves through and creates more contact time with the fabric to help the fabric kind of grab onto the sediment particles. Uh, Again, this is another picture of the pond. On the left picture here, you can clearly see there's a turbidity difference between what's in the, outside the skirt and at the skimmer. And this right picture here is the actual outflow from that pond. I definitely wouldn't drink it, but that's pretty clean water compared to what's in the basin itself. And so after about 2 years of monitoring this, we felt like we'd finally come up with a good system. We had TRI Environmental do some testing for us, and they confirmed that we meet a 90% TSS removal rate, which we were really excited about being able to hit that, as that's going to, you know, meet the requirements in most areas. Now, our testing was done to an ASTM standard. So a lot of people don't know that ASTM now has standards for sediment removal. So the standard is C1746. Um, there's specific requirements on soil gradation, flow rates, how you do the testing, all that kind of stuff that gives the lab clear instructions on what to do. One of the things to point out when we did this testing is, with ponds have a lot of features that help, right? They typically have a forebay. You got that travel distance. You may have some vegetation. You may have a vegetated shelf. You may have all kinds of things that would help in sediment removal. Um, and obviously, you have dry ponds and wet ponds, and typically wet ponds are considered to be better for sediment removal, better for water quality than dry ponds. So what we did is we set this up to test it as a dry basin. So it kind of went up and down as a dry basin. We took away the forebay and travel distance. So here on the right is where we're introducing the sediment laden water into our tank. And this is our outer skirt polyethylene, filter here. And this is our inner, and this is the skimmer. You can see here it's pretty turbulent water coming in, but this water you barely tell it's moving, right? So although the skimmer's got a pretty good flow rate going out, it's not enough to really pull that sediment particle up to the skimmer to be discharged. So we did that. Again, we got 90% TSS removal. We tested 2 versions of the skimmer. One got 92, one got 96. So TRI was comfortable in scaling that out to apply to all our skimmers. So we've now installed what we consider our commercial version back in that sediment basin or detention pond rather. This is a pretty good picture. You see how steep these side slopes are. This side is about the same, but you can imagine just trying to get down into that basin, have to clean out all that muck in the bottom. And then the skimmer's working well. It's draining the pond properly, and we've got this out there. It's been out there about a year and a half now, and we're going to keep it out there basically until it falls apart. The biggest question we get asked on this is how long does it last? Well, the skimmer itself is a HDPE polyethylene high density polyethylene product. It's got a 20+ year life. we're very confident in it being very durable and UV resistant. The filters, because we tested the first version for 2 years, right now we're saying, we recommend replacement every 2 years. Obviously, if you've got a pond that has excessive debris or maybe some large stuff in it that damages the filter, you may have to do that. But you can see there's a lot of trash and debris in this basin. This pond's in about a 40-acre watershed that's all commercially developed, and almost none of it has any other stormwater management. So this pond gets a lot of junk and debris, as you can see from that 6 foot of debris fill up that they had before. But we felt like if it's working here, then it's going to be working just about anywhere. So why would you want to consider filtration in a basin versus settlement? So what are some benefits? So number one is your peak rate of discharge can be based on your filter treatment flow rate up to whatever first quantity storm event. So what I'm saying is rather than settlement based, you've got to hold that first flush for 24 to 48 hours, depending on your area, and you're relying purely on settlement for treatment. If you've got filter, well, you can release that water at whatever the filter can handle up to whatever that first quantity storm event is, which in most cases is a 2-year storm. So you can actually let that water, that first flush out faster. You're still going to be under that 2-year storm event. So typically not going to be an erosive kind of rate. There's not going to be flooding anybody downstream if it's less than a 2-year storm. But you can, if your filter can handle it, that's what you base your release rate on. The other thing is that filter is going to treat 100% of runoff from storms up to that peak rate of the filter. So what happens when we get a small storm, say quarter inch, half inch of rain over 6 hours or 8 hours, right? Get basically in the pond and out the pond. And so if all of our water quality for basins is based on settlement, ponding and settlement, and you get no ponding, i.e., you get no settlement, how much treatment are we getting in those events? Whereas with a filter, it's going to treat those very small events and potentially treat larger events too. And then the other one here is the filtration media can be customized to target specific pollutants of concern. So we've already incorporated the adsorbent fabric in our design. The adsorbent absorbs hydrocarbons. It's got great testing on that. We have not tested it in a pond to absorb hydrocarbons. There's really not a standard that I've been able to find on how to test for that, but they've got adsorbent has testing data on that. They've got testing on metals removal, and we're going to be working on nutrient removal. The dissolved portions of nutrients are going to be hard to do, right? I'm not sure, without some sort of chemical reaction, you can take that out. But a large part of your nutrients are particulate. They're attached to sediments. And so if you get 90% of the sediment out, you're getting a large part of the nutrient removal out. Those of you in Virginia, I know you're looking at a TP-based water quality. We're working with the Virginia to get approval for that. We provided our testing. We're going through some processes with them now to see if we can get on the approved list for water quality products with this. Got a little bit more work to do, but that's in the process. So that's why you'd use a filter. So why would you want to use a skimmer with a filter? So the skimmer can be used to control that peak rate for lower storm events. So let's say you've got a 5-acre site, you can size that skimmer to manage your peak, your flow rate for your 2-year storm, and that's your low flow orifice now, not a hole in the bottom. The skimmer is going to increase filter efficiency by withdrawing from the surface where the water is cleaner. So by the skimmer staying at the surface, the filter is not having to work as hard. It's not staying at the bottom where the sediment concentrations, pollutant concentrations are higher. It's being pulled up, with the pond floating. So it's cleaner water already. So it's not having to work as hard. And the skimmer is going to make it easy to access or pull to the side of the pond for maintenance and changing filters. So, maintenance is a huge deal no matter what you do. Ponds are designed to capture sediments. They've got to be cleaned out occasionally. But obviously getting to something in a pond, you can pull it to the side much easier than say going into a vault with confined space entry and those kind of requirements. So it's not a perfect solution. We admit that. So there's some challenges. So number one, Your filters are prone to clog over time and going to require maintenance and periodic cleaning or changing. You can't put this out there and leave it forever. As I mentioned before, we're recommending every 2 years to replace the filters portion of the product. The other thing is your skimmer's got to be durable and last for more than a few years to be suitable for permanent use. Some skimmers are not UV resistant. You really need a UV resistant product. There's ours, at least one other out there now that's pushing for post-construction use. And I think it's great that the industry is not just us. Other people are coming along saying, you know what, this is a good idea, and we think skimmers are a good idea as well. And then our biggest challenge is really, and I don't know how many MS4, I know we have a couple of city or county folks on today. There are no established standards or basis of design for permitting based on a combination of a pond and filtration. Most stormwater manuals include standards for pond design based on settlement time, on that first flush model. Um, there's very few we've seen, if we're really none, that we've seen that combine a pond and a filter. We've seen standards for MTDs or proprietary products that, manufacturer products, what the basis is for approval of those. And we're following along with those tracks for these, but there are really no combinations of that. So we're kind of breaking new ground. And, for all our viewers, we understand, you really need something to base that on. What can we hang our hat that this actually works so that you know what products to approve, what products not to approve. And that's why we've done the ASTM testing, and we're in the process of getting NJCAT testing done as well. So kind of wrapping up here, we're going to go over a quick example to kind of compare a first flush release over 24 hours versus a filtration-based flow rate of filter modeling for water quality. So let's look at a sample site. Let's say it's 5 acres. Let's just go from our wooded, type B soil, curve number 55. Let's say we're going to turn it into a shopping center. We've got a curve number 92. So based upon that site, we're going to do our pre-development flow rates. So we're going to focus on our 2-year storm. So 2-year storm came out to 0.72. I didn't model this. We had a question about HydroCAD. This was actually done in HydroCAD. 10-year storm is there for you. Again, we're not going to focus on those. That's part of your water quantity calcs, which you got to meet pre and post. We're going to focus on the 2-year storm and water quality. So next step, you're going to look at your water quality volume and your post-development flow rates. So, I've got a hypothetical 5-acre site, time concentration is down to 10 minutes. So what's that water quality storm? Well, in South Carolina, it's 1 inch of runoff volume for the site is your water quality requirement. I know we've got people from Georgia here, it's 1.2 inches. I had somebody from Tennessee, I believe it's 1 inch there. In North Carolina, it's 1 inch, 1.5 inches. I will, full disclosure, I'll tell you, those of you in North Carolina or doing design in North Carolina, North Carolina is probably not going to accept this product quite yet because of the NEST program, and we haven't been through that yet. So we'll work on that, and we'll see if we can get our NJCAT approval or STEP program approval. Maybe they'll accept that, but the NEST program makes it difficult in North Carolina. Anyway, trial and error, we came up with a 1.73-inch rainfall event in 24 hours is going to generate that 18,150 cubic feet of runoff volume. So, right. So how much rainfall we got to have to actually generate 1 inch of runoff? So that's the answer, 1.73 inches for this site. So water quality flow is going to be 7.23 CFS, and our 2-year storms jumped all the way up to 19.72. So it went from 0.72 to 19.72. So major increase in flow because of the amount of impervious area added. So most engineers have a spreadsheet similar to this. It'll take a first flush calculation. So we can look at a dry pond. Here's our contributing area. What's that volume required? So in case for a dry pond, it's 1 inch. In most areas, if you have a wet pond, you can reduce that volume down about half. But we're focusing on dry ponds as they're probably the most common. Water quality volume, you're going to hold it for 24 hours. So, okay, we got this volume. What's the flow rate we need to release that? 0.21 cubic feet per second. Now let's say, okay, here's what orifice size with average head. Go through the spreadsheet, spits out 0.21 foot orifice or a 2.6 inch orifice. So I kind of said, okay, in the model, let's assume contractor's going to put a 3-inch pipe there. That's pretty close to 2.6. Let's run it that way. 3 inch, we'll put some kind of low flow orifice, trash guard, something to try to keep it from getting clogged. we've got a hypothetical pond takes 3 feet of depth to have our water quality volume of 18,150 cubic feet. Typically, you can't put any other orifices in within that depth. So now we're going to put in a 3-inch orifice right at that 3 foot depth. That's going to control our 2-year storm. We'll have an 8-inch orifice 2 feet higher to control our 10-year storm. And then our um, riser is going to handle the 25 and our spillway is going to handle the 100. All right. So run the numbers here. So our water quality storm, we're releasing it at 0.25 CFS, gets a peak elevation of 12.5 feet. Remember, we've got basically 13 feet or 3 feet of here, and it's really 2.5 feet there. Volume required to manage that water quality event, 10,700 cubic feet. Again, we've got 18,000 cubic feet because our spreadsheet, assumes that that entire volume, poof, magically appears instantaneously in the pond, right? Well, that obviously doesn't happen. There's an inflow, outflow hydrograph in there. So you're really only using that much volume. So you've got that's 7,500 cubic feet or so of volume that is not being utilized in the design of the pond. It's basically, I won't call it wasted because it does factor into the overall flow rates, but it's not being used as effectively as it could. And our 2-year storm has a 0.81 CFS outflow with our 3-inch outlet. Again, our pre was 0.72. Depending on where you are, someone may allow a less than a tenth CFS increase. Consider that insignificant. You may have to drop that down and put in that 2.6-inch or 3-inch outlet here or something there in order to tweak that to get it down. So now let's look at the alternative to base it on a skimmer. And so we're going to look at our 6-inch skimmer with a 6-inch orifice is a 0.7, has a 0.778 peak flow rate. And that peak flow rate is at a depth of 4 feet. So we're trying to hit that 0.72. So here's our skirt detail. So you can get the inner skirt, the outer skirt. One thing I want to point out here is some of these get pretty large. We had to base the size of the filters on the testing for our 4-inch skimmer, and our 8-inch and our 8-inch max have substantially higher flow rates. So everything's scaled out. And what we did is we maintained the flow per square foot for each skirt or inner and outer. We also maintained the flow per linear foot. So what we said is, let's assume that the filter was entirely clogged and all flow had to come under, or assume that all flow went through, or any combination thereof. These are designed for. So the filter will never impede the flow of the skimmer. The skimmer will always be what's controlling. Here's the detail for the basin. Pretty self-explanatory, a lot of the same information as the other. You may have a minimum and maximum flow rate in here. For post-construction, you may just establish an exact flow rate because you got to make sure your pre and post match up. So now if we run the numbers on this, our water quality event is now going to be discharged at 0.7 CFS. And so the peak elevation is now only at 12. So it's a half a foot less in the basin. And we're only using 7,600 cubic feet of volume versus the 18,000 cubic feet required. So about just a little over a third of the volume is actually being used for water quality, which allows us to use more of that volume for controlling the other storms. So the skimmer is now controlling our 2-year storm. So it's releasing at 0.78 CFS. So, we've got the skimmer attached here. We've got our 8-inch orifice. It's been able to drop down a little bit to control the 10-year storm. And our riser structures dropped a half a foot to control the 25. And our emergency spillways dropped down another foot to control the 100. So what happened is you reduce the volume required in this basin to get the same flow control and water quality, versus a traditional riser. So that's the comparison in storage required. It's really easier to look at it percentage wise. So for our water quality storm, you're looking at a 29% reduction in volume required. 2-year storm, 14, 10, 25, 100. So the idea is you're reducing the size of your pond. You are treating 100% of the storms, the tiny storms, in this case, all the way up to a 2-year storm event, to a 90% TSS removal efficiency. and you're doing so with a product that has been tested to show it meets that. So if you're in a state, I know Tennessee is, and Georgia, where a dry pond by itself doesn't meet water quality. They've said, hey, dry ponds just aren't going to get us to 80%. Some states allow it, others don't. Well, this is a really simple add-on to get you there. Georgia, we've had several MS4s review this, and what they've said is, hey, we'd like to see some additional testing, maybe NJ-CAT approval. We see what you got with TRI, but we're only going to give you 50% TSS removal instead of the 90% your testing did. Well, when you combine that with the removal credit for a dry pond, you get up to the magic 80%. So you still meet that 80% requirement, even if we only got 50% TSS removal with our filter, at least in Georgia, how they base it. So again, kind of wrapping up, skimmers are less prone to clog than orifices at the bottom of the pond, and they're going to have less maintenance. So maintenance is always a big issue. So whatever we can do to less maintenance, a good thing, right? Skimmers, I didn't mention this. Skimmers would be a very effective way to retrofit existing basins to reduce maintenance and provide enhanced water quality. We showed the case study how we went in and retrofitted from a 2-inch orifice low flow to a skimmer, and help with the maintenance there. For water quality, if let's say you're redoing a shopping center, you can and you've got to provide water quality. Say the pond was put in before water quality requirements. The filtration idea may be a great way to retrofit and maintain that 2-year flow rate. Obviously, surface withdrawal releases cleaner water from the basin, so you get enhanced water quality. Even if you just use a skimmer without the filter, it's going to be better. I don't have testing to show how much better, but it is going to be better. The skimmer has been tested third party to show 90% TSS removal efficiency. We talked about how the skimmer treats more than annual rainfall, very small storm events up to large events when you got the filter on there. And you're going to reduce your pond size by 15 to 20% over traditional first flush method. I'm going to skip that because we're right at 12 o'clock. So wrapping up, just a couple of quick things about us. This is our website. The main thing I want to mention is we have this resource and training page. So we have our last several webinars are on here. They'll say what states we focused on. So if you're in a specific state, you can pick which one to watch. We also have a video series where we break down into 10 to 15-minute segments. Some are a little less actually, but each kind of topic. So if you don't want to have to go listen to a whole webinar or find in the webinar, you can go to our series and pick the topic you want. We have some things we didn't talk about today. Those of you in South Carolina use SEDCAD. We have how to use SEDCAD with it. For the HydroCAD, that's the only one I don't have up here yet. I'm working on getting that one finished up and polished to get it up. Hopefully have it up soon. And then last thing, we have our engineer spec pack. You download that. There's it's a zip file. There's 3 folders in there, and it'll organize it to your skimmer details, your sediment basin details, and your water quality basin details. All of them include design tools, guidance, etc. Last thing on our skimmer, again, it's HTP product, has the debris guard. We say works in subsurface drain, continues to work in mild frozen conditions. Again, mild is the key word there. If you're in Minnesota or Indiana, that may not be the case. This is our orifice plate. We talked about that in a detail. This is a little quick example of how easy it is. So it just shows how you take it out, rotate it. You've got this little metal, technical term is nub. It goes here and helps contractors get it. It perfectly centers it around across the orifice. So very easy to change flow rates, and all of them have been third party. Always stays level. We redesigned this back in 2019, but the previous model was a little top heavy, tend to lean. And it comes in 6 versions. So anywhere from 2-inch to our 8-inch, and we have another one called our 8-inch max. The 8-inch max, our standard 8-inch uses a 6-inch pipe. Our 8-inch max uses an 8-inch pipe, has a flow rate of almost 2 CFS, which is nearly double most other 8-inch skimmers out there. And like we mentioned before, it is built into HydroCAD. So if you go to use it in HydroCAD, it should be there. I'm going to out of time, and I'm respectful of everyone's time today. If you would like a PDH certificate, please email us at info@rymarwaterworks.com. We'll be happy to send that to you. Appreciate everyone joining today. If we can ever be of assistance, the thing I'll leave you with, if you're an engineer or consultant that says, hey, that filter sounds pretty good, I'd like to use it, please reach out to us and let us know where you might want to use it. We will then contact that reviewer. If you know the reviewer, help us with that contact information, be great. But we'll do that heavy lifting for you. We understand it's new. There's going to be some reviewers out there that are going to go, not going to use it here. I don't trust it yet. And that's fine. Others are going to be like, yeah, that sounds like a great product. Let us help you with that. And we'll be happy to do that. So if there's any other questions, that's the end of my presentation. So you can feel free to unmute and ask or put it in the chat. But thanks for everyone joining today and hope you have a great rest of your week. Okay. Seeing none, appreciate everybody getting on. Have a great day.